Testing. It's working. Oh, well. It looks like some of you are all done. If you are done, feel free to turn your paper over, send it over towards the middle here, and I'll grab it. That one's yours, so you're pointing. I see it. I believe you guessed. I'm not rushing you. Coming down the home stretch. Hopefully you guys are finishing up here. I know you got it last though. You sure? You know, I don't wanna. Okay. Good. so many words on these. All right, that's the one. Okay, I think I got them all. Anyone holding out on me? Okay, staple. Yes, it always feels so good. Okay, so let's see how I did. Hopefully I got them right. Every now and then, though, just to warn you, I do get something wrong, and some student, especially in calculus, for some reason calculus this semester has been a little rough. But here's what I got. So let me know if you think that I got something wrong. This is a little bit tricky because we're trying to deal with the English language, and the English language is horrific. I'm trying to learn French now, and French is more logical than English, but it's difficult to learn a new language. And so if you're not used to math, the language of math, it's difficult. So, but English is terrible. The financial analyst believes, so I'm looking for the claim, I'm looking for something that someone is believing or trying to show is true, or if it says claim like it does in the second problem. And then, so what does this person believe? They believe that the upcoming year will have a higher proportion. Higher proportion, higher than what? Oh, higher than this year. Here's this year. So this financial analyst believes, that's the claim, it will be higher. So the proportion, and this is a proportion. So just to remind you, and by the way, if you got these wrong or if you didn't use symbols because you didn't know what symbols to use, it's okay. This is a good time to learn better now than in 2 weeks when we have our exam. So when you get to the claim, remember it's either going to be about a proportion or it's going to be about a mean. So these are proportions, percentages, fractions, whatever, and these are means or averages. So if you see the word proportion or percentage, then it's probably going to be this. And if you see the word mean like you did in the second one, it'll be this. So that'll at least straighten that out. And then you have to get the correct symbol. It'll be greater than. It'll be higher than. Higher is greater than. So there's that. Then the opposite, hopefully you can deal with that once you have the claim. And I'm pretty, I try to be as fair as I can because as you probably can figure out, this snowballs. And that is to say that if you get this one wrong, then of course this will be wrong if you've done it correctly. So what I usually do is if you got the first one wrong, I read with you and I say, okay, if you think that the claim is P is less than 0.4, then you should write down P is greater than or equal to 0.4, if you understand what I mean. So I try not to be, I try to be as fair as I can with the questions so that if you get this wrong, it doesn't mean that you're definitely going to get all the rest of them wrong. And then, of course, if you get these two wrong, it's possible to still get the third one right if you're careful with how you interpret null and alternative hypotheses. But anyway, these are my claim opposite of the claim. Once you have these, the null hypothesis is always no difference. Null, no difference. And so that would be the equal sign. And you can either write it the way I did, like this, or if you prefer, you can do it the way that Newton did. P is equal to 0.4. So either one of those I'm happy with. I just prefer this just for consistency. Since I'm going to write this and this, I just pick the right one and then the other one. This is right-tailed. And once again, if you switch these around, then the tail is always based on the alternative hypothesis. So as long as yours corresponds, if you picked left-tailed, then maybe you had a less than here instead of a greater than. But greater than, another way to look at this is, since that's a greater than symbol, you can take that greater than symbol and turn it into an arrow, and that's to the right, over there somewhere. So that's right-tailed. All right, so that's that first one. Okay, maybe, I don't know. You'll have a chance, though, to get this right again, because we're going to have similar problems on Monday on the quiz, and then, of course, in 2 weeks on the exam. So don't be discouraged if you didn't use symbols or if you didn't use the right words or whatever it is. So that's what I was looking for, though, in the red. The green is fine, too. Okay, now let's deal with this. Here I've also highlighted the average cholesterol. So we have that word average. So we know, oh, this one's an average. And it's got the word claim. And then this word different from. So those are the words that I'm looking at. I don't care about the rest really. I mean, you got some medical assistant. Okay, that's a nice story. But, and also this business about a sample, the sample of 30 patients. At this point, I don't even care about the 30 patients. All I care about is the claim, and that involves that sentence right there. I could ignore the rest of this and I'd be fine. So, in fact, here, let me just show you what I mean by this. Where's my marker? How can I make my marker fat? I don't know. I know I can make it fatter, but here, let's just do this. I could just completely ignore the rest of it. That first sentence is all I really needed. The rest of this is irrelevant. Okay, so the claim. The claim is that the average is different from 220. There you go. So if the other stuff is not pertinent to the problem, just ignore it for now. It will be pertinent when we get to the rest of the hypothesis test. So it's not like it's irrelevant. Then the opposite, if you have not equal to here, the opposite will be equal. And then you just have to sort out which of these is the null hypothesis and which of these is the alternative hypothesis, which hopefully you did correctly. But once again, I will read with you when I grade these things. Yeah, things get complicated. The next test always takes me longer to grade than the other ones for a bunch of different reasons. I always get it back to you the day after you take it, though, unless you take it late. And I do my best to get it back to you. But anyway, and then that's two-tailed, of course. So there it is. There's the whole thing. So any questions, complaints? I can erase this, though, because that'll be important later. But right now, it was irrelevant, the 30 patients in the sample. Yeah, so if you used this number, that's a common, oh, yeah, that's right, common mistakes. Okay, here's some common mistakes. So let me go over here and show you some common mistakes that you might have done. Some of you are going to be like, oh, yeah, I did that. Okay, so here, common mistake. Here's just to try to help you not to do this, is to do something like this. Null, you know you got to write that down, and this. And so then you do something like this. Let's see, where is my claim? Higher than 40%. Okay, so you'll do something like this. So you see what's missing? What's missing is the mu. You need the mu there because if you just say greater than 0.4, well, what's greater than 0.4? I don't know what you're talking about. Oh, no, this isn't mu, is it? It's p. Let's get rid of that. Put a p in there. Yeah, so you need the p. So that seems to be a common thing that students will do, is you'll just leave off the parameter, the thing that we're studying. So I don't know what it is that, well, I do, but it's not correct. It's like you're saying a sentence and leaving off the subject of the sentence. So there's that. Let's see, what else is mistakes? I guess another mistake is to use the wrong symbol. So like I almost did up here, this is a proportion. So pay special attention to what the problem says. When you've got a proportion, you're going to deal with p. And when you see average or mean, here's average, you're going to be using mu. And do your best to make a nice mu. I know it's hard. Do a U and then put a tail on either side. Make the one on the left a little bigger than the one on the right, and then I'll be super happy. All right, were there any other questions? I know I just blabbed for a long time, but is there anything that you're seeing here that you're like, wait a minute, I don't understand why it's this way, or is this okay? Those sorts of questions. Okay, so it may be that when I grade this, wherever I put this stack, I think I put it in my backpack, it may be that I come up with some other comments I'll make sure I share with you on Monday. Okay, so today, what are we going to do? We're going to do more hypothesis testing. We're taking this slow. Oh, I should warn you, let's see. So next week, on Wednesday for sure is a Microsoft Excel day. So Wednesday, you need to have your computer, laptop. This may work with an iPad and with your, what is it called? The Linux or whatever it is that you have, Chromebook. So it might work, but if you want to be sure that it's going to work, then you definitely want to get a computer from the from Motherboard to do that. So that's next Wednesday. Maybe I should write that down since I'm talking about it. So Wednesday, Tuesday. What is that, November 6th? November 6th. So for sure, that's going to be Excel Day. I'm not sure about Friday yet. I guess I have to think about how much we can get through on Wednesday. It's a little bit longer of a process to do a hypothesis test on a computer. But once we get it set up, it's going to be like the confidence interval where we'll get it set up and then you'll be able to use it and all will be well. Okay, let me get back to where we are in this thing here. Let's see, here it is. Okay, so this is just a reminder of the hypothesis test steps. And so we're kind of slowly going through this. And that is, we talked about the claim. The claim is always what you're interested in, what you're testing. The opposite of the claim, you know how to do this. If you have a claim, you can figure out the opposite. So this is just a quick review. You have the null and alternative hypotheses. That should be an A there. And the null hypothesis has the equal sign. So this is stuff that you're hopefully familiar with because you did the homework. Oh, sorry, I just remembered something about homework. I get emails from Newton, and they tell me, oh, you have 2 students who are struggling with this particular topic, or 1 student. It's usually not very many. And so I figure, if you're that 1 student, though, I do care about you. Like if it was 30 students, well, we don't have 30 in here. If it was like 15 students, then I would be like, oh, there's a problem. We need to redo this. But usually it's 1 or 2. So if you're that student, though, that's struggling with a topic, please do come see me. I'm here. I will make you a latte in my office if that'll help you. A hot chocolate, if that's your thing. But whatever it is, tea, I'll help you out in the morning, or even on Tuesday and Thursday. I'm happy to see you. So there's that. Also, I noticed on the email I got this morning, it didn't say that anyone was struggling with this topic, but it said, here, I'll show you. Let me just show you, because just so you know what I'm looking at, it doesn't tell me names. Here we go. I certainly could look up names. I could figure out who these people are. I just want to show you what, so that you can see what I'm looking at is, so it gives me this list. It's like, oh, you got a bunch of people here. You got 2. I can click that and find out who the 2 are. And all that means is that there's 2 people who are still back in central limit theorem, which is 2 weeks ago, who got a bunch of problems wrong. So if you get a bunch of things wrong, so notice that all 3 of these are things that we did like a week or more ago. This one's really old. But if you're one of these people, I might click those and find out who. I won't do it here in front of you, but please do come and see me if you're struggling. If you're like, I can't get through this, I'm happy to sit next to you. I've done that for some students here as well as in the past. You go to my office. We've got these tables like this in the outer office. You don't even have to come into my office. Just outer office, you do your work, and then when you get stuck, I say, click that, do that, and then you get it right, and then you get through it. So then you can stop struggling. Okay, enough of that. Let's get back to this. So please do, if you're struggling, please do come see me. Okay, so getting back to this. So you did your homework. It was on this. That's why I thought about the homework thing. Sorry. Okay, so the extra question that we have to remember to ask is, what are your hypotheses? Are they left, right, or two-tailed hypotheses? So we've been through this. So that's where we stopped. So today, as you can guess, we're going to deal with the next, is it 2 or 3? We're going to find out. For sure, alpha. We're going to deal with alpha. Then we're going to deal with what distribution you're going to use. Well, actually, we're not. We're going to skip that. But we're going to go on to the p-value. So alpha and the p-value are the 2 things that we're going to focus on today. Then next week, on Monday, we'll deal with these 2 things. Decisions, summarizing results in a complete sentence. We'll kind of hint at this stuff today, but we're going to focus mainly on alpha and the p-value. Okay, so what is alpha? Alpha is sort of our cutoff. It's like, you remember I did that magic trick at the beginning, or I don't know if it was beginning or if it was during probability, but it was there was sort of like this this idea that if I could guess the first, there were three cards, if you remember. The first card, you told me what the number was or whatever, and I told you the suit. That was a 1 in 4 chance. So a 1/4 chance, not super impressive. It's not all that, not all exciting. The second person, you told me what suit you had, and I told you what number it was. And that was a little bit more exciting because that's a 1 in 13 chance. And then the final person, I didn't know anything about their card, and except, well, I did know, obviously. But if I was just guessing, it would be a 1 in 50 chance. One out of, because there's 50 cards left that hadn't been chosen. So 1 out of 50 chance for this card, which I was able to guess. So the alpha level is kind of like where you draw the line in terms of whether or not you think something is interesting or not, I guess, is one way to put it. Is like it's not all that interesting for me to say, I can predict, let me cut the deck, I can predict that the next card is a black card. That would not be very interesting if it was. Okay, yeah, I know. It's just I got lucky, right? It's a 50-50 chance. But if I were to say, cut the deck and say, the next card is the ace of clubs, that would be exciting, wouldn't it? Huh? Oh, I got it wrong. Okay. Well, you get the picture, though. So, so what would be interesting? What would be exciting? What would make you say, "Oh, look"? Now, alpha is the reason why we call we're interested in this is it actually represents a particular probability. It's a probability that I just got lucky, right? So just predicting the color of the card, there's a 50-50 chance. You say, well, it's just a 50-50 chance. Your alpha level is 50%. Well, actually, that's the p-value, but let's not get into that. Yeah, it's black again. Oh, whoop-de-doo, right? So that's like the probability. It's a probability statement. So here's literally what alpha is, and we're going to look at this in terms of some of the stuff that you have on your homework. It's the probability. It's sort of like a cutoff for the probability that you end up concluding that the alternate hypothesis is true, but actually the null hypothesis is true. Let's sort this out because this is kind of hard to understand these words. Null hypothesis, alternative hypothesis. So here, let me do it this way. So alpha is so let's see. We're going to conclude we think something fishy. Is that a phrase that people use these days? Or do you know what that phrase means? I just realized I'm old. Something fishy is going on means that, it's something like you've got a card up your sleeve, whatever. Okay. So we think something fishy is going on when really it was dumb luck. Okay, so to demo this, we can demo this. No. Let's let's demo it. Here we go. Here, we'll just have Noah do this. I know it's kind of boring, but here, Noah, just pick any card you like. I don't care. Okay, so you just set it aside, or you can look at it. Okay, very good. Okay, so he's got his card. Do you know what your card is? You sure? Yeah. Because when I do tricks with some students, they forget. And they're, I don't know if that was my card. Like ace of spades looks different from an ace of clubs, right? Okay, you understand that. Okay, so here's his card. And just to make it so that, I'm going to decide that the alpha level for this trick, I'm going to set the alpha level to be, he's double checking. That's good. So I'm going to set my alpha level to be 0.05. That is to say, if I can do something where there is a better than 0.05 chance, better than 1 in 20 basically, then probably something fishy is going on. Otherwise, you're just going to say it was probably just you got lucky. Okay, so here's how I'm going to make sure that it's a 0.05. If I put another 20 cards down on top of his, then there'll be 21 cards. If I can pick his card out of those 21, then it's better than 0.05, right? So let's count off 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 15, 16, 17, 18, 19, 20. We'll put the rest here. So now we've got Noah's cards. We have the rest of the cards. There are 21 cards here. I'm just going to set them here so that you can see it on the screen. And now I need 2 other volunteers to give me some numbers. Just a minute. I will do this. Oh, I haven't done attendance yet. That's okay. I can still pick a random person. Notice I'm not going to touch those cards. Don't worry. Let's cancel this. Random. There you are. Alex. I need to have, let's see, I need 2 numbers. First of all, we'll do Alex. Just a minute. I'll show you the cards. Then you can see that I'm not doing anything funky with them. Okay, here we are. There they are. They're so beautiful, aren't they? Okay, I didn't mess with them. Okay, so Alex, any number between 10 and 20, let's say. 15 is good. Okay, so what I'm going to do is I'm going to take these cards and I'm going to count off 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There we go. Okay, now I need another volunteer. Evan, you pick a number between 10 and 20 as well. It doesn't have to be the same as his. In fact, it'd probably be more interesting if it wasn't. 19. Okay, you're going to make me do my work now. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. I think we all agree that I didn't choose those 2 numbers, and I had no control over what numbers there were, and now Noah's card is somewhere mixed up in the middle there, right? I don't know where it is. Well, I think I probably could figure it out using some math, but what I'm going to do is, and I would have done this no matter what numbers Alex and Evan picked, I'm going to just take Alex's number and just do it a second time, and then we will find Noah's card. So let's do 15 now. Was your number 15? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Done. And this here is Noah's card. Is that right? Very good. So thank you very much. Yeah, no one's clapping. It's okay. So how did that work? So let's just go back. Let's go back to this. Oh, let's see. Keep. Okay. So yeah, I should have had Noah hold up his card so everyone could see it, because you might not believe him. He might be in cahoots with me, but the chances that would just, if it was just a random chance, it would be like a 0.049 chance that would just happen. And so the conclusion is, since the chances are lower than this, we're going to conclude that it wasn't just dumb luck. And in fact, it wasn't. In fact, you could pick any 2 numbers. So you can do this trick yourselves. You can pick if you have a stack of cards, pick any 2 numbers between half the deck and the whole deck. That's the only thing. That's why I said between 10 and 20, because I had 21 cards here. And honestly, if you had picked 10, it wouldn't have worked. So I'm glad you picked more than 10. So you do this. You can do this in your dorm. Just basically take a stack of cards, and however many cards there are, have someone pick a number between half the number you have and the full number, and then count off that number, and then have someone else pick another number in that range, count off that number, and then go back to the first person number. And what happens is the bottom card ends up on top. And mathematically, you can prove that, but we aren't going to do that here. But that's how you do that if you wanted to amaze your roommate or your special friend later on. Okay, so that's what we're interested in. We want to know, is what we just saw, is it more interesting than whatever alpha level we have set? So the way that we sometimes represent this is we represent it on a normal curve, and you'll have something like this. Like if we have, let's just pretend that we have a left-tailed test. I don't know what that thing, this card trick would be, but let's just pretend we have a left-tailed test. This would be something like, I think that the average is less than 25. I don't know. That would be an example of a left-tailed test. That would be the null hypothesis, the alternative hypothesis. The null hypothesis would be, you could either do equal to or greater than, however you want to do it. So one of the ways that we'll represent this on a curve like this is sort of like with the deck of cards here. We want to evaluate whether or not the sample that we got. So here's what this looks like. We have our hypotheses. Here's 25. Put that in the middle of the normal curve. And then what we're going to do is we're going to take a sample. And that sample will have some average. And of course, the average for the sample won't be the same as the average for the population. It's almost impossible for it to be, well, I would go so far as to say it is impossible. You will never get a sample to be exactly the same as a population. Okay, I guess you could, maybe. You might get lucky, but by lucky, I mean astronomically small odds. You might get the sample to be exactly 25 if the actual average for the population is 25, but reality is that if you take a sample, it'll be a little bit bigger or smaller. How much bigger or smaller is the big question. And if you think this, if this is what we are testing, then this average will sit on this normal curve somewhere, and let's just suppose that the average is right here, wherever that is. So we want to know, is that far enough away from 25 for you to be impressed that this is probably not just due to random chance? If I had started off with just 2 cards, or 3 cards, let's go with 3, and had Noah pick one of these 3 cards, and then did some sort of a, shuffling or whatever, and then said, here's Noah's card, that wouldn't be quite as impressive because you would have 3 that you're choosing from, and that's just a 1 in 3 chance. I probably got lucky. But if it's a 1 in 20 chance that I just got lucky, then it's like, well, probably not lucky. I mean, it would happen every now and then, but not very frequently. Okay, so that's the deal, is that we find our average. It's somewhere over here, let's say, and from that, we use the normal distribution to come up with a probability. So this is going to be the p-value. Oh, I'm getting ahead of myself. So the p-value, we compare the p-value with alpha. So here's the rule that we're going to focus on this much more on Monday. But the p-value, if the p-value is less than alpha, then you're like, hey, probably not by chance. This is probably not just chance that this has happened. It's probably something more than chance. And then if the p-value is greater than alpha, you'll just say, it was dumb luck. Now, the way that we express this will depend upon our claim and our hypotheses, but that's the sort of philosophy that we're going to be working with. Okay, p-value. Let's deal with the p-value. Oh, so many words. I'll highlight the important words. Yeah, you don't want to write all this stuff down. That's terrible. Okay, so the p-value. The p-value is probability. Of obtaining, it's basically, it's about the sample there. I don't know, that may be not enough, different from the parameter. Yeah, so you have this null hypothesis and you say, okay, here's what I think, I'll put this right back up, trust me. Here's what I think is true, and then you grab your sample and you say, oh, the sample isn't the same as the hypothesis, but if it was really close, you'd say, oh, yeah, just chance. But if it's far away, so that's the question is, what's the chances, what's the probability that you see that your sample is as far away as it is? And notice that this says as different or more than that. So we're always interested in, like, if I ask, like, what's the chances of being this far away? It means that and further. So that's why I've shaded all the stuff to the left on my normal curve. So that's what a p-value is, literally. And we'll have Excel compute the p-value for us because it's going to be a normal curve, normal distribution. Okay, so let's see. We've done that magic trick already. And so let's do practice Uh, let's see. I'm concerned about the Newton stuff, so I'm going to switch over to Newton. I know I've got some stuff on Newton that we need to look at. So give me a sec here. I had it up earlier and now it's disappeared. So it'll just take a sec for me to pull this back up. I mean, it might be on one of my other tabs. I just don't see it. Okay. So we'll go back. I've got some more PowerPoint, but I want to make sure I hit this so that because there's some weird stuff. You remember like last night there was some weird stuff on the homework. And so here's some weird stuff here. Okay. Give me a sec here. Okay. Okay, so lots of words. This is what I wanted to point out to you is this thing here. So there's going to be two sections in the homework where you have this normal curve. And so I want to make sure I at least do one of them because what it's asking for and how you do it, it's a little bit tedious. And I feel the pain. Yeah, I had a little trouble trying to do this myself when I was practicing with this yesterday. So let's take a look at this. It says blah, blah, blah. We have, let's see, critical values of negative. We'll be talking more about critical values next week, but basically those are sort of the cutoffs for how far you need to be away from the middle in order to say, it must not be random chance. It must be something other than random chance. The test statistic is the one that we care about. So if you want to complete this problem, what you're going to do is you're going to, first of all, find that test statistic. So the test statistic is negative 0.5. We'll talk about how to compute the test statistic next week, but it's just a point on the normal curve. So I'm going to find negative 0.5. Negative 0.5. And this is the tedious part, is I found that I would overshoot and then go, you know how it is, like it's a little bit touchy at times. So there's that. The critical values, we'll get to that in a minute. The claim, where is the claim? The claim that the average is different from 2900. Okay, so since the claim is that the average is different, that's a two-tailed test. And so on here, when you get a two-tailed test, you're going to choose this bottom one right there. So two-tailed. So there's two-tailed. Now we have one more thing that we have to do, and that is we have to put these critical values on here. So it's a little tedious, but I think that it's useful to be able to internalize to some degree what the connection is between this is hypothesis tests and normal curves. So this is 1.28, yeah. So I'm going to move this here to 1.28, 1.28. Yeah, this is tedious. And then this one goes to negative 1.28, negative 1.28. Come on, buddy. Bless you. Almost. Come on. You know, I don't know that it's, oh, come on. I guess I'm going to find out. I don't know that it's essential that we get it right on the nose. I mean, you know where it's going to be over here somewhere. So what this represents, the purple stuff, represents the idea that if your test statistic, which is related to whatever it is that you did, so you did some card trick or you gathered a sample, you have a test statistic. The test statistic, if it is over here in this purple region, what that means is that the probability of that happening is lower than alpha. And if it is over here in the white region, it means that the probability of that happening is greater than alpha. So if you're in the purple region, you reject. So what happens is you're going to reject something. What you're rejecting is the null hypothesis. Now we're getting into hypotheses. But anyway, here, let's see. So let's see there. Okay, I guess I need to actually write this down. Give me a sec. Here, I'll put it on here. Okay. And then, yeah, I thought that I could wait till Monday to do this, but I guess I have to do it now because I want you to do the normal curve stuff. So here's the deal: is when p is less than alpha, or if the test statistic is in the rejection region. So, and I know that all of this stuff is foreign. You're like, what is the test statistic? Yeah, we're just playing a game now, I guess. But on Monday, hopefully we'll bring it back to reality. When this happens, here's what happens is you reject the null hypothesis and you believe the alternative hypothesis is true. So that's what happens when P is less than alpha and when P is greater than alpha, or if the test stat is not in the rejection region, then you don't reject the null hypothesis. And how do I say this? Yeah, you don't believe that the alternative is true. You don't believe H sub A, the alternative. Yeah, there's a lot to take in. Let's go back and see if we can apply this. Here, I'll put it both up at the same time. Is this small enough? Can I move it? I can't. But I can make it. Just a sec. That way we can have both up at the same time. So I make this small, where you can hardly read it. Just a sec. We grab this, make this smaller so that it's very hard to see. There it is. Okay, so now we've got them both. Okay, so here's the deal, is one of two things will happen. Either your test statistic will be in the rejection region, or you've computed a p-value. But in this case, I have a rejection region. And so if the test statistic were over here or over here, I would say, I will reject the null hypothesis and I believe that the alternative is true. But since this is in the middle here, I don't reject the null hypothesis and I don't believe the alternative is true. So let's see if I can pick the one that is the correct one. So there is not enough evidence for the business to reject the null hypothesis because the test statistic does not fall in the rejection. Well, there it is. So you're going to have to sort of interpret the words that we have here. I believe that's correct. We're going to find out. Yes, it is. All right, good. All right, well, I'm glad I did that because I didn't realize that it would be quite like this. Let's switch to another. So you see sort of how to do that. I just want to show you one other one. Oh, it's right here, and I can't switch to it. Yeah, this will be easy for you down here, and this will be easy. So let's go. I'll just cheat. I'll use the instructor cheat for now. Give me a sec. So apparently it doesn't matter. Okay. Okay, here we go. Here's another one of these, but this one doesn't have it in terms of a normal curve. So here we have, zoom in. I don't even know what SEO means. Wait, is it time to go yet? No. I thought people were restless. Okay, so the SEO specialist is studying how satisfied companies are with their website's conversion rates. I don't know what those words mean, so I'm just going to hope. So they state that the average percent of companies that are satisfied is greater than 27%. So immediately, what happens in my mind is I think, oh, mu is greater than, wait, no, it's not mu, it's p. P is greater than 27%. Let me show you what I've written right here. So that's what is going on in my brain when I read that. So that's the important part. We want to test whether this is true. Whoops. And we're going to use a significance level of 0.05. So what happens here is that we have the alternative. So this is the alternative hypothesis for our test, and the null hypothesis will be the opposite. And it said that alpha is 0.05, 5% for alpha. Alpha is 0.05 is our cutoff. They want to know, what does alpha mean? So what does alpha mean? Well, it means that there is a 5% chance. So let's go back here. I'll say it and then I'll pick it. there's a 5% chance that we believe that this is true, and that we reject this, reject, whoops, whatever. So there's a 5% chance that we do that despite the fact that the null hypothesis is true. So it could just be due to dumb luck or random chance that we get a proportion that's so big or whatever, but there's a 5% chance of that happening. It's gonna take you a while to sort all this out. You're gonna get some of them wrong, but you know how Newton is. It will let you try and try again. It'll send me an email saying that you're struggling, and I'll feel bad for you. But if you are struggling, please do reach out and I'll try my best to help you. So which one of these is the right one? There is a 5% chance that we conclude that the alternative is true when in fact the null hypothesis is true. That's the right one. Okay, there was another one. Just a minute. There's one more type of problem. Is this it? First move the blue dot. Let me see, this might be it. So this is a greater than is right-tailed. So here's right-tailed. And then what do I do here? I need to make this 5%. Why is it so weird? Okay, then apparently I need to move this until the rejection region is 5%. So you see that rejection region there? You gotta change, there it is, 0.05. So the rejection region is 0.05. That's what it wants you to do, is to move it until that's the case. And then you're like, yeah, that's great. And I think that's it. Let me just double check. This one here, yeah, this is similar to what we've done. Oh, yeah, I guess this is a little bit, one more, and then we'll be done. So this one gives you a chance to change the alpha level. So I don't know if we had that with the other one. So it's the same idea where we choose the correct direction. Let's see, this says different from, yeah, bear with me for just another couple minutes, different from 17%. So it's not equal to, so that's a two-tailed test. So if you want to do the bare minimum, here's how I would suggest you do it. First of all, figure out the number of tails. So in this case, because of different than, this is going to be two-tailed. Then it says the test statistic is calculated at 2.43. So I'll go down here and move the test statistic to 2.43. 2.43. Okay, got it. So there's 2.43. And then it says that alpha is 0.01. So I'm going to need to change my alpha level here to 0.01. Once you've got all of that done, you're going to look on this little curve here and compare the, let's see, you have the rejection region is over here. And so this is not in the rejection region. So I'm going to assume that this is due to random chance. Now I realize 1% is really small. There are reasons why sometimes we choose to have our cutoff be 1%. I think that you'd all agree that 1%, it would be amazing if you were to think of a number between 1 and 100. If I were to be able to say that number, that would be pretty impressive. But for statisticians, it may not be impressive enough. We'll have to deal with why we would, change alpha or change the cutoff, and it has to do with what we're studying. There may be a reason why we want to set the bar so high or low, depending on how you look at it. But anyway, so here the test statistic is clearly within the outside the rejection region. Rejection region is the purple stuff. It also gives you a p-value for this test statistic. And so let's go down and see what it says. Okay, there is not enough evidence to suggest that the alternative is true. So let's see, there's not enough evidence to suggest that the percent increase is not, I know that's kind of like a double negative, but that's literally what we're doing. We have a two-tailed test, so these are not going to be used because those are one-tailed. So it's not 17% is what we're really interested in, And since we are not in the rejection region, we're not going to reject the null hypothesis. So there's not enough evidence to suggest the alternative. And that's the alternative. So yeah, do your best with these. You know how it is. You're gonna get a few wrong, and it's okay. Stick around if you want to